As you're looking at that paper that was handed out to you, is there anything on there that you're looking at and thinking, I just don't have the faintest darn clue? C2 and 4. Okay, I got to take a roll here. Okay, so there might be a misprint on here. I'm not gonna lie. C2NH3 or C2NH. Is that what I heard? Okay. All right. Well, let's go ahead and take a look. Okay. And it could very well be, like I said, that might be a misprint. Okay. And since I have that twice on the back, I'm willing to bet that that's one we're going to throw out because I'm willing to bet it's just a typing error. But let's go ahead and take a peek at it because I just don't know if we've got enough hydrogens. I just think we have one too many hydrogens for a double bond. So I don't think this single bond business is gonna pan out. Let's just take a peek. Okay, so if it was just CnH4, that would be fairly straightforward, wouldn't it? See, right. But then when we do that, okay, so again, it would appear to me that perhaps this single bond business isn't going to work unless, let's try something. That takes care of one hydrogen. Now, is this right? I don't know. That's why we do trial and error with this. Okay. Then we could say, oh, all right, we could do one there, and it looks like you might think we got it home free, but probably not quite because this one is a little short. You could say we could do that, but that's not quite going to work. Well, what about if we take these two guys that's probably where I didn't account for that X there. So that was there, and then we made a single bond there. 1, 2, 3, 4, 5. So I tried to put 6 there, so that's not going to work. So now, that dot from there, and there, and I don't think we're getting any closer. We still have one too many hydrogens, it looks like. Okay, so I'm interpreting that's just a typing error. So what that tells you then is if you didn't have that back page done, what does that tell you can do? Because we said we've got one too many what? So then when you look at the back page, what does that tell you? Okay. So again, that C2NH4, we throw that one out. Okay, now, as we look at that, it's on there twice on the back for a reason. So now we know a single bond doesn't work. Okay, well, let's look at this business of a single bond between the carbons works, but it has to be, one of them has to be a triple bond between the nitrogens. So let's see once what we can do here, as opposed to maybe if we did a single bond here. Well, that's not going to get us any closer. Maybe we need to do a double bond between the two. Okay. What, you mean moving that over here? Well, then it's the same compound. Yeah. And you could say that about ozone too, but when we look at resonance structures, that's associated with double bonds, not triple. But that is a good way of looking at it. There's no doubt there. So again, a lot of this, and I don't have an answer key for this. I just like to keep doing this from year to year, because otherwise I may forget the best way to instruct you people. And I think that's a good analogy, is rather than always having an answer key to go by, I think it's really easy to become complacent. Or I had always thought in college, and this is probably going to happen to you. Let's say, for instance, this is an algebra or calculus class, and this is possibly what can happen to you. You're asking questions, and you got the professor, well, I got this example here, so he just writes down what's in the book and says, well, that's how you do it. That doesn't help you much, does it? And at the college level, yeah, I understand it's probably more expected of you, but let's not throw you on the deep end of the pool right away. But anyway, so let's try this double bond here. Okay. So that leaves, we can get rid of 2 hydrogens. Okay. So that takes care of that carbon. Now, what we need to do is work on possibly, if we put an X here for that hydrogen, and let's maybe chew up another hydrogen there, which means we've got an X left on that carbon, and then maybe make a bond here for that nitrogen, and then 1, 2, 3, 4, 5. Wait a minute here. I know that, okay, so that single bond isn't working. But I'm thinking if we had that C2NH4, 1, 2. Oh, okay. There's 4 right there. What am I thinking? I'm changing the formula. You can't do that. I was seeing if anybody was paying attention. Did anyone catch that? How many hydrogens do we have here? How many do we have in the formula? No one said anything. Why is that? Yeah, maybe so. You can just set it there for now. It's fine. So that's not gonna work. So let's see here. Well, since that carbon's taken care of, now 2, 3, 4, 5, and then 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, C2, NH3. Okay, there we go. Does that look right to you? So my point is, again, we don't have all the answers either, and I think it would be foolish to say that we do. I can't see how that works. Yeah, I'm sorry. Did we not say we needed to change that or throw it out? Oh, sorry. But anyway, so now we know. Correct. C2NH4, I don't believe we can do that. Okay, well, let's go ahead and take a look at it. Man, if we get all these done today, what are we going to have you do tomorrow? More? Oh, you like this stuff?
Not a worksheet, but we need more. I need more practice.
More practice? Well, you can look up inorganic compounds and organic compounds and do those dot diagrams. I mean, we don't have to think of everything here, do we? Yes.
It is kind of just like there's no real like method to it. You gotta just have to see what works.
Trial and error.
And then for double bonds, so like carbon can double bond, right?
Yes.
Can it double bond with another element, just like any other element it wants, or does it have to be another element?
Just only carbon, nitrogen, and oxygen and sulfur.
Double bond with each other.
Yes.
So like a carbon can double bond with like. All right.
No. Metals cannot double bond. Because remember, they're the nice guys. They give their dollar bills away or $5 bills. See, I think this is a classic point. Here, I'm going through the concession stand and I buy, yep, I didn't know if I wanted a candy bar, but okay. So I said, I want just a regular Coke. So I reach in my pocket, $2 bills, and away we go. Well, there's a student behind me who gets the same thing, and they pull out a 20, and I said, I don't have that problem. I just have dollar bills, and I just carry dollars. Everyone else carries 20s. This is a student. So what are the chances are that that student had that given to him from mom and dad? Maybe yes, maybe no. I don't know. I'm sorry. I'm picking on your brother. Yeah.
No, okay. He got a job and then spent all his money before someone got home.
Do you think? Sometimes you thinking, is that even possible? Okay. Okay, so C3H6O. It's everything other than column 8 and column 7 and the metalloids. Okay, so when we're talking about metals, okay, we're talking about these two columns all the way over to here to this zigzag line. Because on the zigzag line are the metalloids. So they haven't really decided, am I going to be a fan of the National League or am I going to be a fan of the American League? So the reason I say that is if you know anything about it, the American League has a designated hitter, the National League does not. So it's kind of like they have not made up their mind yet which rule they want to follow. But I would not worry about that with that of the metalloids. Even though aluminum is on that line, aluminum is a metal, and so is boron. Okay, the rest of them, you don't really need to worry about that as far as if that's going to be in a compound. Okay, so don't worry about antimony there or germanium. Just worry about aluminum and boron because you know what the charges of those two are. On your table, it doesn't say anything about boron on there for a charge. But when you look up at this one, it does tell you +3. So one of the things we don't want you to look at this table and say, what charge does boron have? It doesn't say in here. Well, we just told you. It's in the same column as aluminum, so it's +3. All right. Yeah, yes, that's correct. Okay, one of the things I'm willing to bet that I had looked at this compound, the C3H6O, I'm willing to bet that is an organic compound. Everything This is also an organic compound. This, as I look at that, I'm willing to bet that that is actually propanol right there. And that's one of the things that happens when you take organic chemistry. For those of you who maybe watch CSI Los Angeles, CSI Antarctica, CSI New York, CSI North Pole. See where I'm going with this? There's a lot of CSIs out there. Oh, well, we're going to start one, right, Tom? That's right. See, that's where it would be classic. Someone's going to say, and I would have got away when it wasn't for those meddling kids. You know where that comes from? Scooby-Doo. That's right. We just need a Dalmatian now. Or not a Dalmatian. Why am I drawing a blank? It's not a Dalmatian. Those are the ones that ride fire trucks. Great Dane. That's what I'm thinking of. Okay. So the point I'm getting at is when the reason that something like this is important when you're watching them crime shows, and okay, we've got this unknown substance, and then they might show you a picture of their computer screen, and it's got these zigzag lines on there saying, oh well, this is saying we got some ethanol in there, and this says, well, we got there's a ketone substance on there, or something to that effect. So what that's doing is that's shooting a laser beam through this substance. It's called a gas chromatograph or a mass spectrometer. And what it does, it's reacting, well, not reacting, but these electrons are bending that laser, and that spits out this image of all the known organic compounds. And that's why they say, well, we found this compound at the crime scene. So, and then we start looking for, well, it's a paint-based substance, and so we need to start looking at all the different paint retailers that sell this specific type of paint to tie that to the crime scene. You know, that's somewhat embedded in science, but yet it makes for good writing and good acting. And see, how am I doing up here? How am I playing the part? I could be, I'd want to be Dr. Hodgins. That's who I'd want to be. Does anyone know who that is? No. No. From Bones. Yeah. Oh, Abby? Abby's the name on there, but she's no longer on the new episodes, correct? They wrote her off the script, I think. How? I don't know. Okay. So with that, so as I'm looking at this, I'm willing to bet that that's what this compound is. And do you remember from physical science when you saw things like this? This is what I'm basing this off of, okay? So we've got C3, we've got 3, 5, 7, 8. Okay, that's off a little bit. Maybe that's a ketone. What about if we take this guy off, put him on there? 3, 6. Darn it, now we got 3, 6. Maybe that should be a 5. For some reason I was thinking, or is that an ether? 3, 5. Dang it. It still isn't working out. Maybe that's an alkene. But anyway, let's just go ahead and try to get started with this. We don't have 2 oxygen, we only have 1. All right, well, let's just go ahead and give it a try. I'm willing to bet that we probably just do not have enough compounds on here, that single bonds is just not going to work. We just don't have the hydrogens. So that's not working. Okay, well, let's try a double bond between 2 of them. Okay. So let's go ahead and chew up some of these hydrogens. There's one. There's one. Okay. Is everyone with me so far? Okay. Well, this carbon still has one left. We'll bond it to another one. And what about if we did this? I know what you're thinking. We got 4, 6. Let's chew up another hydrogen there once. And is that it? We got that pesky oxygen left. Dang it. Just when I think I got this done. Okay. So this dot is for that carbon. Well, let's make a bond there. 1, 2, 3, 4, 5, 6. Okay. We're one short, aren't we? So that's not it. Yeah, you're not authorized personnel. Okay, so that's still not getting the job done, is it? I tell you what, these aren't due until I would say tomorrow, but I'm not going to be here. I said Friday, so let's just go ahead and stick with that. Is this the last one that you're having problems with? Is that C3H6O? Okay, so then just keep on plugging away at that, and then we'll cross that bridge when we get here, or when we get there. And then we're probably going to stick with a problem quiz. I know, well, can we have them papers back? Well, we've got examples that we can look at, so that we've done in class. So if that's not enough, just remember, whether watching this video again helps, maybe yes, maybe no. Come in before school, after school, and we get you pointed in the right direction. So why don't you go ahead and take the rest of the 15 minutes to take a deep breath with the way this class started, so that way we can get through the rest of the day and we don't lose the rest of our hair. All right.